This is the SNAP 2013 tutorial for the supports design cost tab. And this allows you to put in some factors to compute a wall cost, which is important for designing and finding the best design for a wall. So what you'll see is there's a totals here that help you calculate what is the total cost of the wall. So what you can do is put in the average cost of steel per unit weight. In this case I've put in 35 cents per pound, which is probably close to the price of scrap steel, but of course you may want to put in a more accurate value there for just on average for your mesh, for your nails, bars, whatever. Just put an approximation of about how much it costs per pound for that. And then for your concrete, it's the average cost of either your concrete or your shotcrete. These are both combined into a per unit volume, and here it's per cubic foot. So if you know the price of concrete per cubic yard, you just divide that by 27 and enter that into this box. And then this is the cost factor here, this third factor, and it relates material quantities to wall cost. And so typically similar regions, similar geographical regions will have the same cost factor. So if you've already designed a wall in a similar area, or an area close to where you're going to build this wall, you can use the same factor, the cost factor for that. But if you're not sure what this cost factor is, you can calculate it if you know what the cost of the wall is. So if you know the cost factor, like if it's maybe 35, you can put that in and it will tell you the cost of the wall is 1.6 million. But if you happen to know that the cost of this upper wall here, and remember it includes the permanent facing, everything, the total cost of the wall is 1.5 million, then it will tell you you should use a cost factor of 31.9 to relate these steel and concrete prices to the total cost of the wall. And this includes everything. It's equipment rental, shipment, storage, labor costs, everything. So what it's doing is it's assuming that there's a linear relationship between the steel and concrete prices and the total cost of the wall. So if you add more steel or you add more concrete, it's going to increase the cost of the wall. So it assumes they're directly proportional. And then if I go to the second wall, what I'm going to do is I'm going to copy this factor of safety, this cost factor, and I'm going to select the second wall, and then I'm going to use that same cost factor there. And it'll tell me that the cost of this lower wall is $985,000. This is just in there's millions. So this way I can use the same cost factor for both walls, but I don't have to use that. I mean, if you know the cost of the lower wall for this particular design, you can input it and use that cost factor. Then you can use these cost factors, then these will be used later in finding the best design, or a design that eliminates any kind of waste of materials and can give you an approximate cost of what the wall would be.